All right, today we're going to dig into something really cool, a pretty radical new vision for high school math. It's called Advanced Math and Abstract Reasoning, and honestly, it might just change the way you think about math altogether.
You know, for so many of us, high school math was all about one thing, memorizing formulas just to pass the next test. Right? It was abstract, kind of disconnected, and everybody was just pushed along at the same pace. But what if we flipped that? What if instead of rote memorization, the focus was on critical thinking, on seeing the real-world impact? And what if you could learn at your own pace? Well, that's the huge idea we're going to explore today.
So how does this reimagined math actually play out? Let's break down the core ideas behind this course, which is designed for high school students, grades 9 through 12.
Okay, first thing you need to know, this is not a beginner's course. It's what they call level 3, so think advanced, honors level stuff. And the goal here, it's not just about passing an exam, it's about cultivating real innovation, about building a deep foundation for the problem solvers of tomorrow.
So, what's the secret sauce? What's the engine that's really driving this new approach? Well, it all boils down to a core learning philosophy, one that's designed to build, well, mathematical powerhouses. And here it is. The whole program is built on this one powerful principle, mastery-based learning. The idea is actually pretty simple. You have to fully get a concept before you're allowed to move on to the next one. This is huge because it stops those little gaps in understanding from turning into massive walls later on when things get more complex.
And this slide really breaks down that process perfectly. It's a simple three-step cycle. First, you explore a new idea. Now, if you get stuck, and everyone does, you get what's called adaptive support. That could be a different kind of practice problem, a quick video explainer, or a whole new way to visualize the idea. You only move forward once you have genuinely, truly mastered it.
Okay, so that's the philosophy, the big idea. But what does it actually look like in practice? Let's take a peek inside the Innovator's Toolkit, the modern methods and tech that students are using every single day.
So instead of just zoning out during a lecture, students are tackling problems head-on from the get-go. They use these incredible interactive tools like Mathagon's Polypad. It's basically a digital playground full of virtual math tools. And get this, it's not a lonely journey. They use platforms like QThink to record and share how they solve problems, which opens the door for awesome collaborative discussions where they can actually build on each other's ideas. This quote right here, it absolutely gets to the heart of the whole thing. The goal isn't just learning what the formula is, it's about understanding why that formula works and how you can apply it in creative ways. And that, my friends, is the leap from just doing calculations to true mathematical reasoning.
And this is where it all starts to click. This is where the magic happens. Because when you finally understand the why and the how, you can start to see math not just as a bunch of numbers on a page, but as a powerful tool to describe and even shape the world around us.
I mean, forget those boring, static charts in a textbook. Imagine watching a graph of a function literally morph and evolve in real time as you tweak a variable. Or seeing an animation that shows you exactly how interest compounds second by second. These dynamic visuals just bring these abstract ideas to life. And the course connects these abstract concepts directly to the real world. So, for example, you might use probability and calculus not just for some random problem in a book, but to actually model the chaotic, unpredictable movements of financial markets. How cool is that? The course also pushes way beyond the flat 2D page. You're using tools to see 3D geometric proofs rotate in space, building this incredible intuition. And it also weaves in these subtle coding symbols, like using a little bit of code to represent an iterative process, which perfectly bridges the gap between pure math and the logic of computer science. And that's really the ultimate destination here. It's about equipping students with the tools they actually need to go out and tackle the world's most complex, most important problems, whether that's in science, tech, engineering, or finance.
So, after all that, what's the big takeaway? What should you walk away with? Well, it's not just about getting better grades in math. It's about becoming future-ready.
And that really brings us to our final question, the one I want to leave you with. What if the whole point of math class wasn't just to prepare students for the next exam, but to prepare them to solve the defining challenges of their entire generation? That's the big provocative idea at the heart of this whole thing.